Hello everyone, today we're talking about angle measure, section 6.1 in our book. And we've already kind of touched on it in chapter 5, but now we're really going to explain why we do what we do to get from degrees to radians. So first they want me to find the radian measure. Radian's typically going to have pi in it, we're used to that by now. And they have 185 degrees, they want it in radians. So, to go from degrees to radians, I'm going to multiply by pi over 180 degrees. Reason why I'm doing that, if we remember, our unit circle, when we go 180 degrees, when we go back to a straight line, this is pi radians. So pi and 180 are actually the same number, but we're just converting from degrees to radians. So I can multiply by 1, right? I'm just multiplying by 1 just like I can do with any other math problem. I can multiply by 1, that doesn't change the value. It's just going to change it from degrees to radians. So here I get 185 pi over 180, and that reduces down to 37 pi over 36. So 185 degrees written in radian measure is 37 pi over 36. Now if I want to go from radian to degree, they want me to go backwards. Now I'm going to multiply by 180 over pi. So easy distinction to know whether to multiply by pi over 180 or 180 over pi. Our degrees are not going to have a pi in it, right? We don't have degrees with pi in it. So you're going to want your pi to be on the denominator when you're going from radians to degrees, so those pi's cancel out. Then I'll be left with negative 480 degrees. So if you took 8 times 180 divided by 3, you're going to get 480. It was a negative radian value, so it's going to stay a negative degree value. Now they want us to find an angle. They give us an angle in standard position. They want us to find two positive, two negative coterminal angles. So this is just like the worksheet we did in chapter 6, or I'm sorry, chapter 5. But now we're actually going into the mathematics behind it. So I've given negative 155 degrees. I'm just going to draw that real quick so we realize negative, remember, starts going down. So negative 155 degrees is going to look like that angle. So if I want to find two positive, I'm going to take negative 155 degrees and I'm going to add 360 degrees. Positive 360 degrees. So really, that is going to give me 205 degrees, and that's a positive value, 205. That's going to start going up, and you'll notice that that is the same angle as negative 155 degrees. So 205 degrees is the same as negative 155. They want two positive, so I'm going to add another 360 degrees, and that gives me 565. And if I draw that angle, right, 565 is more than 360, so I go around once, and then I have 205 more degrees. So you'll notice that 565 degrees ends at the same angle as 205 degrees and ends at the same angle as negative 155 degrees. So those two positive. Now I'm going to go ahead and I'm going to subtract 360 degrees to get two negative coterminal angles. Remember, coterminal meaning they end at the same point. So all three of these angles end at the same point. We want to find two negatives that also end at the same point. So negative 515 degrees. I'll go ahead and draw. So negative 515 degrees is more than negative 360, so it's going to go around once. And then it's got 155 degrees more to go. So negative 515 ends at the same as all of those degree values. And then subtract 360 degrees more, and we're at negative 875, and negative 875 is more than 360, so one time around. It's more than 720, which would be two times around, and then it's 155 degrees more, again, ending at the same location as the other 4 points. So when they're talking about coterminal angles, they just want angles that end at the same point as the angle given. This can be degrees, this can be radian, and it can be done the same way. So for example, if we had, like let's say we had negative 5 pi over 12, and I want to find, let's just do one positive, one negative. So if I want a positive, I'm going to add 2 pi. Okay, and 2 pi, I want to make sure I have a common denominator. So what I'm really doing is taking negative 5 pi over 12, and I'm adding 24 pi over 12. Right, 24 pi over 12 will reduce to 2 pi. So when I do this addition, I get a positive 17 pi over 12 would be the same as a negative 5 pi over 12. So it ended at the same location. And if I wanted a different negative, I would just start at negative 5 pi over 12, and I'm going to subtract 2 pi. So that what I'm really doing is negative 5 pi over 12 minus 24 pi over 12, giving me negative 29 pi over 12. And that'll end at the same point as negative 5 pi over 12, which ends at the same point as a positive 17 pi over 12. Leading us to the final example. They want us to find an angle between 0 and 2 pi, so it has to be strictly between 0 and 360 degrees. Remember, 2 pi meaning 360 degrees. That is coterminal to 19 pi over 6. So how I like to solve this, I'm going to draw 19 pi over 6, and then I'm going to hopefully find just a small positive angle, small, relatively small, in between 0 and 360. So I'm going to start counting by pi over 6. So if I went just to the straight line, that'd be 6 pi over 6. Right, we've done that, that would reduce to pi. If I come back around, that's 12 pi over 6. Okay, so I still have to go further. 6 more would be 18 pi over 6. And I have to go 1 more pi over 6, getting me at 19 pi over 6. So that entire angle is 19 pi over 6, meaning I'm going around more than one time. I'm going more than 360 degrees. But I want an angle between 0 and 2 pi. So it has to be smaller than 360 degrees. So I need this angle here that goes just from my x-axis to that angle in the third quadrant. So just this smaller angle here. And since going from my x-axis back to my x-axis again is 6 pi, I need to go 1 more pi. So that is 7 pi over 6 is a coterminal angle with 19 pi over 6. That is between 0 and 2 pi. So less than 360 degrees, and it's a positive value. They may ask you for a negative value between, they may ask you for, between 0 and negative 2 pi. And then you just have to go, then you just do a negative value here. So this was not the question here, but just for example, if they asked you for an angle between 0 and negative 2 pi, this here would be not quite negative 6 pi over 6, so it would be negative 5 pi over 6. It's 1 pi away from getting, it's 1 pi over 6 away from getting back to the x-axis, which would be 6 pi over 6. So go ahead and try the example problems that accompanied this PowerPoint. I have done something different this chapter, and the answers are at the end of the PowerPoint. So you can try the examples, and then check your answers with the back. Don't just copy the answers down. Give it a shot, and then we'll talk about it in class tomorrow.